Hello students, today's our topic is common base amplifier. As you know that amplifier is an electronic device which take as an input signal very small amplitude of input signal, or we can say that we take weak signals, the signals which have small amplitudes, and convert them into the strong output signal. It means if in the input we fed a weak signal in the amplifier circuit, then we will have a strong signal in the output circuit. The circuit becomes large in amplitude as compared to the input signal. This device is known as amplifier. Hence, amplifier is an electronic device which converts weak signal into strong signal. Today we are dealing with common base amplifier. Common base is taken from common base configuration of transistor, and today we are considering the transistor type is NPN transistor. Let us consider an NPN transistor and make it common base transistor. This is our common base transistor, and as it is of NPN type, the emitter side is of N-type semiconductor, and the emitter current will comes out from the transistor. The base is P-type in NPN transistor, and the current will move inside the transistor, and this current is our base current. And similarly, this side is our collector region, and in NPN transistor it is of N-type. As emitter current is moving away from the transistor, the base current and the collector current will move inside the transistor. The base is in the input side as well as in the output side. For the proper functioning of transistor, we make the input side forward biased and the output side reverse biased. To make it work properly, the output side should be reverse biased, and as we have to take the output signal also, we will connect our output side with a heavy load resistance across which we will take our output, and to make it work properly, we will make the output reverse biasing. As the collector terminal is N-type, the positive terminal of the battery is connected with the collector, and negative terminal of the battery is connected with the base terminal. And let us consider the potential DC source is our VCC. In the same way, in the input side, we have to give the input signal, that is a weak AC signal. We will give our weak AC signal. This is our input, and to make it in forward biasing, we will connect a DC source across the emitter and base junction. As the emitter is of N type, the N terminal, negative terminal of the battery will be connected, and let us consider this potential source is represented as VEE. That is, this is the basic circuit of our common base amplifier. We have two types of supplies here, VEE and VCC. They are providing forward biasing and reverse biasing respectively in the input circuit and the output circuit, and the small weak signal is applied across the emitter and base junction, that is in the input side, and we are taking our output from this heavy resistance, that is known as load resistance, across our output side. These two DC sources are independent of the input and output supplies. These reverse biasing reverse biasing and forward biasing are independent of the polarities of these two signals. It means the emitter base junction always remain forward bias and the collector base junction remains always reverse bias, and they are not depending on input signal and the output signal for their biasing. Now we will discuss about the working of our common base transistor. Let us consider the AC weak AC signal is applied to the input side. As the positive half of the wave is facing or moving through this circuit, and we know that the positive half of the wave is given to the n-type semiconductor. It means it will decrease the forward biasing, or you are decreasing the voltage applied in the forward biasing. And due to this reason, the ammeter current decreases. And we know that the collector current is approximately equal to ammeter current. The decrease in the ammeter current will also decrease in the collector current. Collector current also decreases. If we see our output loop, we are finding out that this is our positive terminal, and the current will move from positive terminal to the negative terminal in this circuit. And according to Kirchhoff's loop rule, we can write VCC is equal to ICRL, because IC is also moving towards the transistor or inverts the transistor. It means the voltage drop across the collector region has the same direction of current as the current applied with the help of VCC. It means if the C terminal and B terminal are taken as a potential drop or taken as a voltage source between C and B, they will form the closed loop, and according to Kirchhoff's loop rule, we will have VCC is equal to ICRL plus VCB, where VCB comes out to be VCC minus RL. And in our case, VCC is the fixed reverse biasing source and RL is the fixed resistance, that is load resistance in the output circuit. It means change in IC will make a change in VCB. If IC increases, the whole quantity will decrease, because this is a constant quantity. Increase in IC will increase the value of ICRL. If ICRL will increase, the whole quantity will decrease. It means increase in IC will make decrease in VCB, or it means we will get a negative voltage. Now, in our case, when positive half of the input signal is fed, the emitter current decreases, and due to which the collector current decreases, and decrease in the collector current. Here, if IC decreases, the whole quantity VCB will increase. VCB will increase, and if VCB will increase, it becomes more positive. It means the output voltage becomes more positive. Hence, we will have in the output a more positive output signal for a small input signal. Similarly, in the second case, if negative half of the signal is fed to the amplifier, we know that emitter is n type, and if we are applying the negative half of the signal, then the emitter current will increase due to the increase in the forward biasing. Emitter current will increase, and the dependency of collector current on emitter current, it will also increase the collector current. If there is an increase in the collector current, then according to our equation, if the collector current increases, this whole quantity will increase, and as VCC is fixed quantity and this quantity is now very large, the VCB becomes very small. If VCB becomes small, we are taking it is as negative. It means we will have a negative signal in the output. We are getting the input and output are in same phase. For positive half of the wave, we are getting positive half in the output side, and for the negative half in the input side, we are getting the negative half on the output side also. In case of amplifiers, the signal goes on increasing. We can explain it with the help of an example. Let us consider the load resistance is very high and it is of 10 kilo ohm, that is 10,000 ohm, and if there is a change in the input voltage of 0.1 volt, that is we are changing this voltage, that is our input voltage, by 0.1 volt, then this change in the voltage will make a change in the current. Let us consider the change in the emitter current, which is approximately equal to the change in the collector current. In this case is 0.5 milliampere. As we know that the output is depending upon input, and in our case the output is taken from the load resistance, and the voltage across the load resistance is IC into RL, then in this case IC is 0.5 milliampere, that is 10 raised to power minus 3 ampere, and we have considered the load resistance as 10 kilo ohm. We will have the result output voltage comes out to be 5 volt. This is our output voltage, that is 5 volt. If output voltage is 5 volt, it means this is a change in the output voltage. When change in the input voltage is 0.1 volt, there is a change in the output voltage of 5 volt. It means the voltage gain or the amplification in the voltage, that is the change in the output signal with the change in the input signal, in our case comes out to be a change in the output voltage comes in our case 5 volt, and change in the input voltage comes out to be 0.1 volt. It means the voltage gain is in our case is 50. It means if we are applying 1 volt of signal in the input side, we will get a 50 volt of signal on the output side. In this way, the amplification of in a amplifier works. The whole output depends upon the load resistance. If we increase the load resistance, we will increase our output voltage, and this increase in the output voltage increase the voltage gain in our circuit. There is no phase difference in case of common base amplifier. For a positive weak signal, we are getting a positive strong signal, and for a negative weak signal, we are getting a negative weak signal. It means in between input and output there is a phase difference of 0 degree.